That was wonderful. Yeah, let's do Q&A. Does anybody have questions for Mike? Let me see. Oh, Bob does. Okay, Bob, go for it, sir. Oh, sorry, and I'm going to enable it so you guys can unmute yourselves. Sorry about that. Go ahead, Bob.
What you did was a beautiful segue from my presentation. It fits beautifully. So thank you. I wouldn't be so dismissive of 1930s technology. I bought this the other day, and it is called the Osram Vitalux, and it was built in Germany in 1937. It has the original high pressure sodium lamp in it with the tungsten filament, and it still works. Everything is original, 1937.
Wow.
This is the very first UV sunning lamp. Yep. And it's the original bulb. So I can imagine those, and it was built in Germany, pre-war. I can imagine those Germans building what you just showed there. And yeah, your mathematical analysis was fantastic, really. Let's build one. How do we get to build one?
Mike has plans, right? He's got the schematics, he's got the math. So
well, yeah, have you got the team to make it? That's my question.
Talk to Mark.
Okay, well, I think we might be able to find something to help you with that.
And Bob, if you're still with us for open discussion or for Mark's lab updates in a bit.
Fantastic.
Yeah, well, let me ask and see if there are more for Mike, more questions for Mike. And then let me see. And if not, we'll give it a second. And if not, we can go to Mark and the lab updates. But yeah, oh, there's Harold. Harold, go for it, sir.
Yes, my question for you, Mike. I've been wanting to ask you for a long time. What do you know about magnetically induced gyroscopic forces in a spinning disk? Any research in that area have you seen?
Makes eddy currents. The Lear lifter works on that exact principle. They have magnets spinning. Well, the Alexei one you're probably a little more familiar with, but they have magnets rotating, and that generates eddy currents on the disk. And of course, E cross B equals F, which is what gives you the lift.
Because I've been doing experiment in my propulsion system, and I have a spinning disk, and I'm using orthogonal magnetic fields, so that you have Ampere principle in which it's a reactionless force. So you have the vector of velocity crossing a magnetic field, producing a perpendicular force to both of them. My problem is that on the stator, I have a stationary magnet. In the stator, I produce a Lorentz force in one direction. And on the spinning disk, I always get, if it is horizontal disk, I get a magnetically induced gyroscopic force in one direction, always 90 degrees ahead from the application of the magnetic force. If it is the vertical, then I get two forces. I get, the gravity induced gyroscopic force, and depending on where I have the magnet, then I get the other one, the magnetically induced gyroscopic force. And I want to make it controllable, because I can align both of them, the magnetic force, the gyroscopic force and the Lorentz force in the same direction, or they can be 90 degrees apart. But one thing is that unstable, the gyroscopic force make my system unstable. The force, fluctuate, depending how I'm changing RPM. And I wanted to know if you know any research in that area that have been done so that I can see how can I control it, the gyroscopic force, or eliminate it.
Yeah, what you're describing is very similar to a homopolar engine or motor, where you have a disk in a magnetic field, and you have the normal electric motor cross vectors, and then you have, somebody just dropped out. You have the additional gravity ones. Now, precession seems to be what your problem is with gyroscopes. When you mention changing RPM, that changes on the gyroscope, and then they start to precess because of the cross vector problem, I guess you could call it. I don't know if that helps any.
Fluctuate, you know. The problem is, like, for example, if I have a spinning disc horizontal and I have it, you know, let's say at a 3 o'clock position, I have a magnetic field. Now I can align it so that the Lorentz force would be straight out, you know, from a perpendicular to a 3 o'clock position. Now my gyroscopic force would be at the 12 o'clock position, a straight line. So they're both parallel. And I have a video on YouTube showing that. And my problem is that when I get RPM, you know, for example, changing, you know, the stuff sometimes fluctuate a little bit to the left, the gyroscopic force on the right, the Lorentz force very stable. But the gyroscopic force, you know, like you said, maybe it goes left or right, you know, and that kind of make my system unstable. That's the part so I'm familiar with the homopolar motor, but I want to know if anybody have done research on a magnetically induced gyroscopic force, because I have not had any luck finding any papers in that area.
Well, the only way you can fix it or cheat a little bit is to run two discs spinning opposite directions to cancel. That's the easy way to fix it.
Oh, it's true, but I rather have one. I can only produce one disc. You know, I have to have both of them in line. What I want to do, is there a way to eliminate the gyroscopic force? You know, probably what Bob Green was asking about, all these magnetic forces, and I want to know if there is a way that I can use the magnetic force, you know, maybe some material that can give me a feedback. Instead of creating gyroscopic force, have a feedback that I can send back the energy that will be used for the gyroscopic force back to the stator, so that it can produce all Lorentz force and make it more stable. Because I've done it also with 2 unit, you know, both magnetic field spinning. There are certain rules about it, which I will be publishing, I hope, by the end of December in my website in Academia EDU. That's the part I want to know, any papers. But I mean, you're right. You know, it's the precession. That's my problem. I want to eliminate. So no papers in that area. You know, I have to.
I don't know of any. The only way I know how to fix that is to spin a disc in the opposite direction to cancel it.
Well, 2 discs.
Yeah, you have to have 2 discs to do it.
Well, I found out, you know, I tried that, but it become more unstable. You know, the whole thing, you know, start rotating. But if I use, for example, if I have 2 of them, they have to spin in the same direction to make it more stable. And that's one of the videos how you
gotta
do.
go opposite. They got to spin opposite to cancel.
Okay, because I tried that, you know, and the result I got more unstable. But anyway, but I want to try that again, you know, maybe I missed something. All right, thank you. Great presentation.
Okay.
Very useful. Thank you for all those equations you put there.
Thanks, Howard. Thanks. Let me go to Charlie next. Charlie, go for it, sir.
Great. Yep. Thanks, Mike. Yeah, great presentation. I liked your comparison to the gravel flyer design. Oh, I gave a presentation on that, and I was wondering your thoughts on, you show a raw down the center of your Tesla drive to create that, you know, different, the DC and then the AC. With the gravel flyer, the 3 legs have the high voltage AC from the Tesla coil on it. So how does that maybe compare to yours? And you're saying 2 counter rotating discs versus the one you showed. Oh, it's not a disc, but it's a moving charge.
Right. It's magnetic. Platter spinning magnetic, which is a magnetic opposite direction, which is similar. The Lear lifter and your Alexei lifter have fixed magnets that do the same thing.
Okay.
What you're generating is magnetic pulses. That's the name of the game, is you generate a magnetic pulse. And depending on how many magnets you have and the RPM you're spinning them at, and that determines how fast or the pulses are, but that's what you're trying to generate is magnetic pulses.
Okay, interesting. What's your thought on controlling it, like right, left, forward, backwards? Yours just goes up and down.
Well, if you look at the full details, there's 3 gyroscopes down on the base that also work as landing gear that they use for steering it.
Okay, gotcha. Okay, thank you.
Awesome. Thanks, Charlie. Okay, so let me see who is next with questions for Mike. And we'll give it just another second, and then let me see. Well, Mike, I think maybe that's it for questions. Okay, well, let me put it back on gallery view then. Everybody, give Mike another hand. Thank you, sir. Thank you very, very much.
At least you can mention flying saucers without getting thrown out.
The government, the U.S. government, now has an official flying saucer investigation place, I guess.
Well, they had Blue Book, which many years ago, and my guess is they're going to do the same thing with this one, is more disinformation.
Okay, well, so let's